that's the reason why this whole idea of a referential thing is referencing what is located here in memory. So as soon as this changes to say, instead of being Bob will make this Bill, this immediately is already set to be Bill. Because it's pointing at Bill in Costa Rica.
It's in debug Windows. And you have to be running something to get it back. I think so. Yeah.
I mean, the guy like reaches to
we might already know of that this type of jump is occurring. So he said, oh, this is like how, because I think he's like, when would you use this? And you're like, all the time. Like, what's an example?
Yeah, my answer to him is actually he doesn't have a choice. The whole language is based off this truth, so even if you hated this, you can't get out of it.
Right.
I'll try. It's hard to come up with real world examples, but so you're a real person. You're completely independent. You got your own brain. And I can write on a notepad your name. What's your name? Annette. Okay. So I could write Annette, and I could say this is the pointer. So whenever I look at that note, I could go, okay, Annette's the one I'm supposed to talk to.
Yeah, I know.
But there's not now two of you. If I created another notepad, or if she created a notepad, also have your name on it, there's now not two of you. There's just two different ways to identify you. They're all pointing at you. You're still you. Doesn't matter how many variables there are, how many user IDs you are in different databases like Facebook or Twitter or whatever. Doesn't matter how many jobs you had, where you have an employee file. They might all have files that are about you and point to you and are about you, but those aren't you. It's not a copy of you. It's not true that a new copy is created every time. There is still just one you.
Sorry. Yeah, they're ready.
Okay.
I was just trying to get
Yeah. I'm going to keep trying to throw out those metaphors, but sometimes I just got to keep going.
It's always so funny because the refs come over.
All right.
We're ready? All right, let's resume. The stream should be up. It is. Great. Welcome back, everybody. I'm going to mention one other quick thing that came to mind to me during the break, and then we will actually change topics rather dramatically. I'm going to use the exact same example here we stopped off with. What I want to do is do person David semicolon. Right? Let me make sure I got a breakpoint. I do not. Let me add one. So what I want to first point out, I'm going to run this. So Alice and Bob are still there. We still have the 5-person variables. So there's 6 pointers at Bob, 1 pointing at Alice. But for now, let's ignore all that and just think about David. So this is starting to run. And we hit our breakpoint. That's great. Now, my locals window is deliberately small. That's good. So I do have a variable called David. What's its type? It's a person. What kind of type is that? Value or reference? Reference. It's a reference. So what does David hold right now, the David variable? What does it look like if I put my mouse over it? Null or zero. You got to pick one.
Well, I mean, for those two values, it's null.
It's null. That's correct. So it is a person, which we already know is a class that we wrote, so we know it's a reference type. If you just have it, so everything I showed you so far was me going var something equals new something. But if you just have David as a type, that means we have a variable named David that's on the stack, but we never said equals new, and we didn't assign it to Bob or Alice. He's assigned to nobody. Reference types that point to nothing are null. Put my mouse over it, he's null. Okay? But if I stop this and add a new line after that, equals, I'm going to stick with Bob. Now I know that line looks confusing to read, so the variable names here are bad. Try not to write your code this way. But for just presentation purposes, I'm going to run this. Actually, I'm going to stop and restart it because I want to put a breakpoint in. There we go. New breakpoint. Now I'm going to run it. I'm using the breakpoint so we can look at what the world looks like, what the universe looks like. So here's David. He's at the bottom of our locals window. He's currently null because we have not run the line that's yellow yet. And if I press F5, it'll execute that line. David becomes pointed at Bob, and if we expand it, he is Bobby. So now there are 7 different variables pointed at Bob, persons 1 through 5, and David. So I was re-emphasizing, I wanted everybody to remember, to point out this line 29, to remember that we wrote the person class. All classes are reference types. So all variables of that type are initially initialized to null. Just like we saw the strings were actually initialized to null. So they're actually null to begin with. If you don't do something David equals new person, which would actually create an instance, without an instance, he himself is null. All right, now I had one more example.
I have a question.
Yes, question.
How'd you do the breakpoint so quickly?
F9.
Okay. I remember.
Yep, just one of the mini hotkeys that have become sort of muscle memory for me. So now, let's do more here. New person. I'm just showing you more examples to try to help this sort of sink in a little bit. And this will probably be my last example if there are no more questions. And then I'll move on to a new topic. So initially, create a variable named David of type person, which is a reference type, so it's null. I'm going to put my mouse up, well, I can scroll down here. You can see David is null. I could also create a new person. Now there is actually a brand new person who is neither Alice nor Bob. It is a David object, but we didn't give him a name or an age, so he's initialized to null 0, and that's fine. I can immediately throw that instance out of existence, effectively, by assigning David to Bob. Now David's pointing at the original Bobby. That Bobby is going to remain forever because there are other variables that point to him. And if I advance one more line, I've done it again. David is now another new David. I haven't given him a name or an age, but I created another one in RAM, and now he's pointed at that. So I wanted to just show that although this is not a real-world scenario, you won't be doing code like this in real products. I just wanted to show I can initially have a David that's pointed to nothing. I can point him to a real person by instantiating it on the fly. I can also point him immediately to somebody that existed already, which Bob already existed, and I can change my mind and instantiate a new one. And in reality, if you scan how many times new appears on the screen, there were actually 4 that were ever created. But by the time I'm at approximately the line I'll highlight, there are only 3 that I have access to. Alice, Bob, and the second David. This interstitial David, this middle one, actually came into existence and was immediately destroyed because I pointed the variable somewhere else. So I'm just showing you that, remember when you write your own classes, they are reference types by default, which means if you don't instantiate something, they are null. David starts out as null before I either create a new one or assign him to a Bob. Just a little bit of a reinforcing example that I thought of during the break. Okay. Now we're going to switch gears entirely. We will come back. Okay, we are not done talking about classes. We are not talking about the fun stuff we can do about them, and that will not be the last time we talk about reference types. But we've talked about them enough that I think it's time to talk about a new topic and see what we can learn from a different point of view. So you'll notice something that I had to do yesterday and today, and you've been doing it yourself a lot. I keep running the application. Right? I keep on pressing F5, or you might be pressing this little green play button, whichever. They both get the same job done. I've been running the code over and over and using breakpoints and console write line to prove to you that what I was telling you was correct. That I wasn't misleading you, that all the stuff I'm telling you is actual fact. That's how the language works. Well, this works in a sort of a learning environment like this, where none of these consoles are, I mean, they're real applications, but they're not worth charging people money for. Right? You're not going to be writing anything this simple in the job because nobody pays for this kind of software. It's not providing a service. When you think of real applications that you've used in life, Facebook, Twitter, whatever you might use, social networking, news sites, if you've used HR software, maybe some sort of internal software to job, those softwares are large. Right? Their scales are large, they rest on large servers, their databases are large, they have large code bases. It's not uncommon to find yourself in a job where there are hundreds of thousands of lines of code, maybe millions. I've been on a couple that had over 1 million. We're writing code here that sometimes has as little as 5 or 6 lines, and it's still sometimes easy to get lost in them. So you might be thinking, well, goodness, what do you do in the real world? How do you manage 1 million when it's hard to manage 10? Are all those good developers 100,000 times better than I am? The answer to that is no. That is not true. But we do have techniques that we use that you're not aware of yet, and one that I'm about to show you. So if you imagine a situation where there's 1 million lines of code, and you're responsible for 100 of them, but those 100 are buried in the guts of that application. So if it's something like Facebook, in order to test it locally, you'd have to run it, you'd have to log in as a user, you have to navigate to the feature, you have to click a few buttons, maybe to put some comments on or a like on some sort of object. You then have to log out as that user, log in as the other user, go to that image, and then see if the like showed up on your screen. Now that is one way to test code. That's what quality assurance teams often do. They usually call themselves QA teams, and I do love them for that work. They do great work and point out some cool bugs and before the customer sees them, which is awesome. I love QA teams, and we work very tightly together. I usually make best friends out of them. But if you think about it from a developer's point of view, that could take like 5 or 10 minutes just to test one feature. Well, if you're working on the feature, you probably don't type it correctly the first time. Let's say that you type it badly 100 times. That's to say your first 100 attempts are not the right solution. It's only the 101st one that works. Well, if you do the math on that, how much time do you spend just navigating the site? Right, you load it up locally, or you go to some QA site, you go to some test site, some development site, maybe an internal version of Facebook that they're running inside the company. You're logging in as one user. That's tedium. I mean, even the way I'm talking about it, my head would explode if I had that job. Which is why I'm so thankful some people are willing to do that, because that drives me insane. I go completely crazy when I have to do the same thing 50 times a day, just to get to that one feature, to click one thing to see if the icon shows up. So the question is, can I test my 100 lines of code out of the 1 million without having to do all that extra work? And I have good news for you. The answer is yes. So we have many tools at our disposal. And basically what our industry has done, we have a bunch of people in our industry who like automating things and making computers do work that humans used to do. And we have come up with a solution, a few solutions, but one in particular I'm about to show you, where we make the computer do the testing for us. All right, we call that automated testing. That's a generalized term for all the ways that developers get out of doing tedious work. And this is a topic I personally am pretty passionate about. I'm teaching it to you rather early. Okay, most people don't talk about this topic possibly for years into their career, but I think it's never too early to make the job easy for you, easier on you. It will be a little bit weird on your brain. You're going to see me do something that doesn't match anything you've ever done in real life. It's going to be kind of weird. But I think you'll appreciate rather quickly that you can surgically test any portion of a C# project without needing to ever run the application, which sounds kind of weird, but it's possible. So we have this concept of automated testing. And automated testing does boil down to a few different mechanisms. I'm not going to talk about all of them. I'm going to talk about one of them. Some people test with products. There's a product out there called Selenium. That's very popular for testing web apps. It basically automates a human, so it actually will click on the buttons for you and fill in test data and watch for responses. Selenium is often used by QA teams. It requires, you don't have to be a developer to use Selenium, basically. You can sort of record a workflow and it'll replay it, which is kind of cool. That's a big thing that I don't actually do very much as a developer. There's also integration testing. I'm not going to be talking about that. Integration testing is kind of the next step deep, where we test if an application is working with certain databases and APIs. That's out of scope of this course. But if we zoom in really close, there's another concept that we call unit testing. Okay, and that term is used a lot. It's becoming more and more popular, which makes me a very happy person. A lot of developers out there don't even really know how to do it, even if they've heard the term. And it's actually, I would describe it as a tragic situation, because they do work the hard way. So I get to go home early, and they stay late. That's basically what it usually turns into. They're there at work, logging into their Facebook or whatever the application is over and over to manually test something. I'm running things that run in milliseconds, and I get to go home. So that's my sales pitch to you. It is in your best interest, selfishly, to work on unit testing and learn what it is. And so we're going to talk about unit testing right now. I do want you to follow along. Do be prepared that this is going to be different. This running unit test is not like running an application. It's going to feel really different and a little awkward. But once it clicks for you, it'll change how you do development. So although we're only on day 2, and some developers don't write their first unit test for a decade, you're writing it on day 2. That's what we're going to do right now. So, and I'm taking this diversion on purpose. I'm going to come back to the values and reference types and all the cool stuff we can do with classes a little bit later. But I want to take a digression, talk about a new topic for a while, and then we'll come back home to what we were talking about. So we're taking a small detour. So what I want you to do is right-click on your solution. We're going to add a new project, but don't click console. Let's get this pop-up here. So we have been creating console applications. Console applications are the things you run from command line. Those are actual executables. We've been doing the console.write line. We've been using the F9 to pause it as it's running. That's kind of cool, but that's not what we're going to do this time. We're going to do what's called a class library. All right? And I'm just going to leave the default name. You can call it whatever you want. I don't really care what we call it. So let's talk about this word. Why is it called a class library? Well, the good news is that's kind of what it sounds like. We've already created a class. We've created a few classes. What's a class library? A set of them. Just a bunch of classes all in a library. I mean, library, you could think of it kind of like a real library. It's just got a bunch of books in it. I mean, anything that's got a lot of books in it could probably be called a library. Anything that's got a lot of classes in it could probably be called a class library. That's all that term really means. There really is no more complexity to it than that. So you can click on it, you can call it whatever you want. I'm just going to leave a default name for me and click OK. Now it's going to create this. Now class library is just classes. You'll notice it automatically creates one for you, class 1. Let's delete that. So if you go over to the Solution Explorer, let's just delete that. Deleted permanently? Yes. Delete class 1. I don't want that. So after you delete it, what you'll find is in that class library, it's got no files. It's got no classes. It doesn't even have that program.cs. You've been seeing program.cs and all these other consoles. You saw that program.cs, and I'll open it just to show you. You don't have to follow this part. It had that static main. That was the entry point. So we could set it as a startup application and run it. And that was its entry point, meaning it would start running the application right at this first line in the main. But our class library does not have that. So if we right-click on class library and set as startup project, we're going to do something bad here, but you'll see why in just a second. If you make it the startup project and press F5 or press play, it won't work. It's going to try. It's going to build it, and then it's going to give you this big red X. That's a good thing. All I'm proving to you here is when you create a console application, that's a real application that can really be run. A class library is just a set of classes. There's no entry point. It's not an application. It does create a DLL in the file system, but you can't run it. It's just a package of code that could be run by somebody else. Okay? So we did set it as startup, but we're not going to actually press F5. So what I'm going to do, yesterday we created an adder class. I'm actually going to pull that adder class into this class library. So let's find, I forgot which one it was in, console app 7 for me. You might need to do a find. If you ever need to do a find in Visual Studio, Control-Shift-F will pop up this search. So if I was not able to find it, I could type adder here and do find all, and it would scan the whole solution for me and help me narrow down where it is. I happen to find it just randomly here, but console app 7 is where I put it. Harper last night uploaded a copy of this code, so if you pulled that down, and for you it would be console app 7. And I'm going to kind of cheat here. I'm just going to copy and paste the body of this. I selected the whole thing and pressed Control-C. You can also right-click and do copy. I'm going to go to my new class library and do add class. Remember we did that a few times yesterday? Let's add this class as adder, A-D-D-E-R. So all I'm doing is copy and pasting the class. I don't want to use the original. I want to have a second copy. Usually we don't copy and paste code as developers, but for the sake of this demonstration, I'm using copy and paste here. I'm going to paste it in. Now I know I'm moving kind of quick. I've just done it in front of you pretty quick. Just do what you can to keep up. Once again, make sure you notice where I am in the Solution Explorer. I'm on a class library. which is nothing more than a set of classes. I created a new one called adder, and I copied and pasted the body in. I didn't want to have to retype this class from scratch just to test it, so I used copy and paste. I see people are still working on that, so I will wait a moment. Now I copied and pasted this class as I wrote it yesterday. And if you remember, we ran this class a couple times, right? We ran a console app and used this class, and it actually worked correctly. But I want to mimic something that happens in the real world, which is we're all human and we make mistakes. So I'm going to add a bug to this real quick. It now has a bug in it. And you probably don't even notice what I changed. If you weren't watching real close, it actually has a bug and it's broken. I changed the plus to a minus on line 20. And I wanted to do a bug that's really subtle. I did something that's hard for your eyes to catch. Because that's where most bugs come from. Most bugs are not some huge mistake you make where you leave out thousands of lines of code, or it's all red underlined, red squiggly. Usually bugs are something much more subtle that nobody notices with their eyes. Even if you show your code to a teammate, they don't notice, and then they have a bug. And if you ran this for a customer, they would see that it calculated incorrectly, and they would be very angry. And then it would be your fault. Right? But we all make these mistakes. I still make them to this day, which is why we're going to be talking about how to test code, because you're more likely to, you're going to be making all kinds of mistakes. Usually when I have code that goes to production, remember yesterday I actually wrote a solution to one of the exercises, and then we went back and tweaked it. Harper gave me some feedback, other people gave me feedback, and I tweaked it. Code undergoes a lot of changes. We change code all the time, and we're usually accidentally adding bugs, and so it's going to be important to test all that. So I've actually broken this copy of the adder class. That's why I wanted to make another copy. I wanted to have one I could break and then change. So it's broken, but how do we know? We can't run this, right, because it's not in a program. And once again, remember the scenario I've set up. I want you to imagine that this is the code you're responsible for on a team, but the actual project is 1,000,000 lines, and it takes you 10 minutes just to run this one time. And you don't want to run it 50 times a day because that's tedious. So we come back to the question, how do we test just this code but never run an application? How do we do that? Unit testing. So how do we do a unit test? Well, the first thing I'll tell you is unit tests are just code. They are code that runs code. That's the first thing to remember. Unit tests are not really that as special as they sound. They're just a way to write C# to test your other C#. The general convention is to put unit tests in their own assembly, which is another word for saying another project. So what I want you to do is follow along, please. Right-click on Solution, Add New Project. And if you look at this list, if you look at it closely, the word test is actually on this list. There are, by default in the latest versions of Visual Studio, there are 2 kinds of test projects. We're going to pick the one that says XUnit. You might ask yourself, well, what's XUnit? XUnit is just a name. There was a project that started years back by a team that wrote some open source software, so it was free for the whole world. It was very popular unit testing software, and they named the project XUnit, and it's now part of this wizard for creating a new project. So that's just the name of a particular kind of unit testing technology. There are many others. XUnit's one of the most popular, so that's what we're going to be using. It's one of the ones you're more likely to see in the field. So if you click on that, you can name that project anything you want. I'm just going to leave the default name. I'm not trying to make the names perfect today. Let me click OK. It'll add a new project to our solution. Now the very first thing that we have to talk about, and I haven't talked about it yet, is you can see we have lots of projects on the screen. And in large, in the business world projects, meaning products you'll actually work on in the real world, it's very possible you'll be on projects that have hundreds of projects. That is to say, hundreds of projects in Visual Studio. I know I'm using the word project in two ways here, I apologize, but that's just the way the world works. We call them projects here, we sometimes call them assemblies, but when you're working on a project for a business, that one project might have a single solution, and we have lots of our projects in it. That's confusing, but unfortunately that's just the way the industry is. There are a lot of terms that are overloaded and reused, and that's one of them. So when you have lots of assemblies, which are these kinds of projects, obviously they need to look at each other and point at each other. How do you access a file way over there in that other thing? By default, you can just access files that are in your own project. How do you access one that's way over there? We do it with these dependencies, so follow along please. You can, in the XUnit project, right-click on Dependencies, and do Add Reference. What we want to do is we want to reference the class library that contains the class that we want to test. So if you look on the right side, I created that class 1 with that new adder that has our bug in it. I can go to this list, and I select it. So in my project, in my solution, I'm clicking on class library 1. If you named that something else, just be sure to pick the one that has that new adder class. And all we're doing here is making sure that the XUnit project can see the class library. We're just making it possible for it to see it. By default, they don't know each other exists. The solution knows they exist, and they're all on this list, but there's actually no real connection between them until we do this. Once we click OK here, now there's a real connection. Now nothing will happen on the screen profound. We've just added that dependency, meaning the XUnit project depends on the class library, and now one of them can see the other. Now that's a one-way relationship. The opposite's not true. The class library cannot see the XUnit project. The vision only goes in the direction we set. Okay? Now we did that because we want to test that adder class from the XUnit project. So we had to point to it so we could see inside of it. And that's what we've done now. Okay. Now it automatically created this unit test class. I'm going to rename it. This name I actually don't like. So I've clicked on the unit test 1.cs in the XUnit project. I'm going to right click and do rename. And I'm going to call it adder tests. If you rename the file on the right, it will actually prompt you and ask you if you want to change the class name as well to match. The convention in the C# world is file names roughly match their type name. So in this case, the actual class. So I'm going to say yes. And you'll notice right here on line 6, they actually renamed that class. It was originally called Unit Test 1, which is too vague of a name. Now it's called adder tests. And I just renamed it because humans are going to be reading this. I want to know what that class tests, what's going to test that adder class in the other location. But we can't actually write the test yet. So although the XUnit project references the class library, that adder class that we want to test, and let's go to it real quick, is in a namespace called class library 1. Right? We've talked about namespaces yesterday. The namespace stuff is at the top of the file all the time. So we have to look at the adder class that we want to test and see what namespace that it's in. I'm actually going to copy that to the clipboard. When I go over back to the unit test class, which is in the other tab, we're going to be going back and forth a little bit here. So you're going to have both files open. But I'm in the test class now. At the top, I'm going to add using class library 1. Okay. Remember what that using statement does. It says, please let me see in that namespace all the classes that are in it, all the types that are in it, even if they're not classes. For us, it's just classes. So because our adder class that we want to test is in that namespace, we need to put that using at the top. It's technically possible not to put it in there, but it makes typing the rest of the code much easier. Much easier to read, much easier to type. So when we deal with unit tests, I'm going to draw your attention here to line 9. Line 9, we've put an attribute on a method. Now I'm not going to get deep into what attributes are. I'm just going to tell you how to use them for unit testing. That fact attribute basically tells the unit test framework, which we'll look at in a moment, please run the following method as a unit test. That's all that fact really means. We're not going to get into why they call it a fact. We're not going to use any of the more advanced features. We're going to keep it simple today. If this were deleted, no unit tests would run because there aren't any. But if I keep that attribute on there, that attribute says this method that immediately follows that attribute, please execute that as part of the unit test suite of tests. So that's all that means. And all you have to remember for the remainder of this course is when you write a unit test, just put that square bracket fact right in front of the method. That's all you got to do. Make sure the method's public and put that attribute on. How it works is beyond the scope of this discussion. Okay? Let's rename that method. I don't like the name test1. It doesn't really explain what the test is supposed to test for. So if we go back to the adder class for a moment and look at what it does, what do we really need to test? We only really need to test one thing, and that is if we add a bunch of values, call that add method, and then call calculate, that calculate better have done the math correctly. Okay? That's all we really need to test. So we're just going to write one test. And test, as I say, and this is what makes unit testing feel weird, right? So far in this course, we've written C#, and then we, the human, tested it. We ran an application, we looked at the values with our eyes, we would look at the console write line, we put breakpoints and we'd look at the locals window. We were the tester. What's weird about unit tests, and what makes them run so fast, is that we remove the human from the equation. We're going to write C#, that tests C#, and then just click run. We're not going to look for console write line. We're not going to look at values with the breakpoints. We're going to make the code look at those values and double check that the addition was done correctly. So let's rename the test. I'm just going to rename it to, since we're just going to write one, I'm going to write calculates, I'm going to spell it correctly. This is a simple enough class that I don't need to have a more formal naming convention for my unit test. Many teams you'll be on that do unit tests will have a very strict regimen about how you should name your tests. You'll just have to fall in line with whatever that team does. But I'm only writing one unit test, so I'm going to call it calculates correctly, because that's all I'm trying to test. Does that adder class calculate correctly? That's the only thing it does, so it's the only thing I need to really test. So how do we write the body of a unit test method? Well, it's actually pretty easy. If you, and you don't need to follow me, you can just watch for just a moment. When I go back to that console 7, look at how I wrote the code in static main. I instantiated the adder on line 9. I then added 3 values. I called calculate, and then I wrote to the console the result. Well, the cool thing about unit tests is you write them almost the exact same way that you write real code, the real code that ran in this application. So, in fact, I'm going to cheat. I'm going to copy and paste, just to show you that how not magical the unit tests are, because they will feel weird when we run them. You're going to be kind of spooked by it. I'm just going to select all 4 of those lines and copy. Actually, I'm going to select more than that. I want that result line too. There we go. I'm going to copy the instantiation, the 3 calls to add with the hard-coded values 1, 2, and 3, and I'm even going to copy and paste that line that grabs the result. So let's copy and let's go right back over to adder tests and let's paste. Okay, and I'm remove that white space line. We don't need that extra space there. So our test, whenever it runs, will instantiate that adder class. It's going to add the numbers 1, 2, and 3, which I've hard-coded. I'm going to leave them hard-coded. It's then going to grab that result. Now what's different, and I will toggle back and forth. I apologize if you get lost a little bit. I have to go back and forth between the screens a little bit. If we look at that program, the very next line we did, that line 15 after the part we just copied and pasted, was we wrote to the console. But that's something you do because you're a human. Right? We write to the console so that our eyes can read it and see that it calculated the result correctly. What should the result be? 1 plus 2 plus 3 is 6. That's right. And we saw that yesterday. But this console line is inappropriate for a unit test. It's inappropriate because that console.write line is for us to read the number 6 with our eyeballs and go, yep, we coded it correctly. So that part we're not going to bring over. Which begs the question, let's jump back to the test. How do we know the result is correct? Well, I'm not going to do console write line, and I'm also not going to do a breakpoint. Breakpoints don't work either because breakpoints require you to read the result. We need to somehow tell the computer This is supposed to be 6. That's what we need. We need one line that says this should be 6. Well, every unit test framework comes with what they call an assertion library. Assert is actually a defined word in the dictionary. It's basically a demand that something be true. So I'm asserting something. I'm saying this is what should be true. So let's type the word assert, and as soon as you start typing it, you're going to see, yep, assert's on there. That's on there because line 2 on the screen, using XUnit, in the XUnit namespace is a class called assert, and it has a whole bunch of assertion methods on it. We're going to use the most common and easy one. It's .equal. If we open paren, it's a method. You can look at the parameter names. Look at those parameter names. The assert.equal takes in 2 parameters. The first one is named expected, and the second one's named actual. So what do we expect the result of 1 plus 2 plus 3 to be?
6.
Let me type 6. How do I tell it what the actual result was? I heard a lot of mumbles, but it's not loud enough. Result. That's right. It's line 16. I have a variable that contains the result. That is an entire unit test. So you'll notice a unit test is really using the class you want to test in really the same way that the real code uses it. And the only difference is we have to do assertions. The reason we have to use assertions is because there are no humans that are going to read the result of this. This isn't a console write line or a breakpoint. Okay? So we've written the whole unit test. This begs the question, well, Derek, how do we execute it? If there's no program.cs and there's no console, how do we run it? Well, all unit test frameworks come with some way to run them. They usually come with multiple runners. We just call them unit test runners. They can be run from consoles, they can be run from different tools that are out there. We're going to use one that's built into Visual Studio because we have Visual Studio. If you go up to the menu in Visual Studio for test, don't click run yet, although you might be tempted. Let's go down to Windows and open Test Explorer. Now this will pop up in different places depending on your Visual Studio install. Mine pops up at the bottom. And you'll notice there was a little bit of green animation. You may or may not have noticed it. And then if you look at the bottom left there, I want to make sure my camera, yeah, good, I'm not blocking it. Just checking the stream. If you look at the bottom left, you can actually see the method we just created. So there's some extra stuff on the screen here, but if you look right where I'm highlighting, there's a section here called Not Run Tests. We haven't run any yet. And look at the one that's in there. XUnit Project 1, which is the name of our project, .adder tests, that's the name of the unit test class, calculates correctly. That's the name of the method. So you can already tell the Test Explorer, that's why they call it Test Explorer, has explored the entire unit test project and found all the tests in it. There's only one, we've only written one, but it found it and it's ready to run it. Running tests is easy. I'm going to right click and do Run Selected Tests. So please do that on your screen as well. So what's actually happening, it actually builds the class library 1, it then builds the XUnit test project, it scans that XUnit test project for the fact attribute and executes all those methods. There's only one of them. It's actually running all of that code. Now it had to build a lot of stuff for the first time, so it's taken a moment on my laptop that struggles with the streaming. You'll see there's some green animation. The first time is always slower. It'll run faster after this. Okay, and then eventually, depending on the speed of your laptop, it should be very unhappy. And that's okay. Remember, I put a bug in that class, so I already knew the test would fail. But I wanted to show you bad news first. That's generally how people who are really passionate about unit tests, and I'm in that group, we generally write tests that give us bad news first and only turn green and happy when we're finished with our work. We're obviously not finished because there's a bug in there. So let's look at why. If you click on it,
I'm sorry, could you go to the adder?
Adder, which one? At the adder class?
No, yeah.
This is the unit test. Did you want the actual class?
Yeah, I do.
Okay. Are you looking for the bug?
No, I know. I remember what the bug was, but
Okay.
mine aren't linked up properly. But that's okay. Keep going. I'm
Okay.
following you.
Okay. So we ran that test and it went red. And you'll notice that it's now in a category called failed tests. Now that feels bad, but I assure you we're on the right path. But if you click on the test itself, the right side here gives you an explanation of what happened. So the message is assert.equal failure. So this line 17 was bad news. We expected the number 6, but the actual result was -6. Okay, now this is kind of weird, but what's happened here, if I had run this, if this were real code in a console and I had put a breakpoint on this line, at that breakpoint, if I put my mouse over a result, it would have said -6. But I don't have to use breakpoints, right? We're doing unit tests. But that's what's actually happened. When that result got calculated, it was -6. Remember why it has -6, because I put a bug in there, didn't I? I changed a plus to a minus. So it's calculating in the opposite direction from 0. So I already know what the bug is, right? Because we wrote this class correctly yesterday. But the bug is in the code. But I want you to pretend, imagine you didn't know that there was a bug in it, that you made a typo. The plus and the minus sign are really close to each other on the keyboard, right? And on the screen, they look almost similar, right? There's only a few pixels off. This is a bug any of us in this room could accidentally create. It's a very simple thing to have one character off in your code and have a bug. So we created this test. We look at it with our own eyeballs. We say it's 1 plus 2 plus 3 should be 6. And we could even pull out a calculator and say, I wonder if we actually wrote the test wrong. So you could pull up a calculator. You could do 1 plus 2 plus 3. No, that is 6. It should be 6. You could look at this unit test and say, well, I'm asserting those are supposed to be equal. The unit test fails. It's that assertion that fails. I must have a bug. All right? So what do? Well, we go to the real class and we scan it, we play with it, we change the code. Let's fix the bug, because we all know what it is, right? You saw me actually create the bug. I could go, oops, that's supposed to be plus equals. Just a slightly different character. I fixed the bug in the adder class, and what I can immediately do is go right back to the unit test, right click, and run. That's a totally different color. That's a much happier color. That's a green color right there. Passed test. So what it means is this code executed. The Test Explorer found this test. We right-clicked and did run. It executed this method. It instantiated our adder class. It called add 3 times. It calculated the result. And it said, I demand that the result be 6, otherwise fail the test. And it went green because the result is 6. This class is now known to work. We actually have a test that guarantees it work. Now you might be thinking, Derek, I could have just ran a console like we did yesterday. How is this more beneficial? Well, I have a long lecture I could give on that, and I won't give it. What I want you to imagine is this is a very simple class. One class in one library with one test. When you're working on a real project, there are thousands of classes, and you could make a change in one over here and it breaks how you're calling this one 3 levels of indirection away, which causes some bug in an even further away class. And those bugs, I'm just telling you from experience, they can take weeks for you to track down. But with a system like this, where you break the project into lots of little pieces and they're all independently tested, your confidence will be a lot higher. You'll be able to find bugs more quickly. Also, I want you to think of what happens in a real project. Now, we wrote this class adder, and let's say we push it out to production. And 6 months later, somebody comes back and says, we want it to do the math differently. I don't know what they would request, but let's pretend they wanted it changed. Well, there's a whole class of bugs in our industry called regression bugs. And this is basically when you're working on something you're supposed to work on and you break something else. So that was written by somebody 6 months ago, maybe you, maybe a teammate. You're working on something close to it but not identical, and you change this. You get your part working, you test it, it works, it goes out to the production servers, the customers see it, but you actually broke this over here. Unit tests help us fight regression bugs because they continually test other things that we're not even working on, and they're also testing the thing that we are working on and keeping us between two guardrails, basically. They don't protect us from everything, but they keep us really close and really safe. Unit tests are a hot topic in our industry. You have people across the spectrum of passion for them. I'm of course really into them. That's why I'm showing them to you so early. It might not feel like this was faster, but I want you to notice in the Test Explorer here, this number 74 milliseconds. Now, I was able to test this pretty quickly for you yesterday manually when I ran the console. But was I able to test it in 74 milliseconds? That's about 1.5 blinks of an eye. No, you had to watch me press F5, step through, pull the screen over so everybody in Winston-Salem could see it, and read the number 6. That takes longer than 74 milliseconds. If you imagine there are thousands of classes and thousands of tests, you can actually test huge swaths of the project in less than a minute. That might have taken you an hour to manually test, more than an hour potentially. So the value tends to increase with the size of the project. So if you're not too impressed by this, I hope you like it. If you're not too impressed by it, just imagine that we're in a classroom and I'm showing you one class. Obviously this adder class is not really valuable by itself. I could not create a company based off this class and sell it for $2 billion to some rich person. No. Real projects are much larger, they're much more complex, they solve a bigger problem, and the more complex they get, the harder they are to test. And that's when the unit tests really shine, especially when you're on a team. Now I just showed you a lot, and I'm going to pause for questions. You had one maybe or comment?
Yeah, I was just wondering if those can be automated and used with your deployment process.
Yes. The question is, can these unit tests be somehow automated and built into some deployment process? Absolutely. There are other terms in our industry, things like continuous integration, continuous deployment. So you can imagine this is a computer running the code. I did right-click this and do run, but I want you to realize that if there were 1,000 tests available, I could just right-click and do run all tests, and all 1,000 would run. It's just a go button. It's a big green, please test them all. Well, you could, and many teams do this, especially the more mature, and even I would venture to say more professional teams, will have a process where when you commit code with Git, everybody's used Git, right? Yeah, we're using Git. When you commit your code with Git or some other tool like Subversion, a computer automatically checks out that code, runs all the unit tests, verifies they all pass, and then can make a deliverable ready for the production server. And if even one test fails, it stops and emails the whole team and says somebody broke the build. And in some teams, I was on a team one time where if you broke the build, you had to wear a jester's hat every day until somebody else broke it. I did have to wear that hat a couple times, and it taught me not to break the build. I'm very unlikely to break a build nowadays because it made me scared of it. But it actually, you can see it actually got a job done. Like that sounds like hazing or humiliation, but what it really is really putting the customer's needs first, is what it really is. I mean, do you think we should be releasing thousands of bugs to customers? The answer is no. We all know the answer is no. You shouldn't be releasing cars that crash all the time. You shouldn't be releasing software that crashes all the time. Right? Both are dangerous. So, yes, Harper, we can make a unit test part of the deployment process. And I really love, anytime I've been on a team that goes to that level, I've always liked working with that team because we're really putting quality as a first priority. And I really love that. What's that?
Less humans in the process makes it nice and smooth.
Yeah, just imagine that. I mean, I've worked on some deployment processes are hard if you do them manually. You know, you have server farms, maybe there's 100 of them. Do you want to create like 100 zip files or just one and then upload them via FTP to 1,000 servers and then remotely connect to each server one at a time and click please install this zip? Does anybody in this room want to do that tedium? I sure hope not. I really hope not. I've had to do deployments. I've been on teams that were that bad. We had to do that. What's much better is to just get the software working on your machine, commit it. All the tests are run by some other server. If they're good, they get auto-deployed. You're on your drive home. You're going to have dinner, and the computers are getting all the work done for you. And that's the world of heavy unit testing and other automation, where we use our skills as developers to do as little work as possible and give as much value to the end user as possible, as much quality as possible. Unit tests are one piece of a larger ecosystem. But I think I'm of the opinion, as you can tell, that it's never too early to show some unit testing. Any questions about how I did this, or anything that's not clear, please ask. There is going to be an exercise really soon where you have to write your own unit tests. So please ask if anything's not clear, and I'll do my best to describe what I did here and why. Anything about the two projects, about having a bug, about what this fact means, anything at all. If you don't raise your hand, what you're really saying is you're ready for an exercise. That's the implicit message that I'll receive.
Can we go back?
You're stretching. I saw
Can
you
we
put
go
your
back
hand back
over
down.
to the other
What's that?
one?
To the adder class?
Yeah.
We do have one. How did you pull up Test Explorer again?
Oh, good question. How do I pull up Test Explorer? There is actually a test menu at the top of Visual Studio, and it's got a Windows option, and it's called Test Explorer. It may pop up in different places on your screen. It's even possible that you have it open and it's auto hidden at the bottom. So if you ever try to open it and it's not doing anything, it might be that you have it open here at the bottom. These are all, they're called hidden. If you click on it, it'll pop back open, and that little pen icon will then keep it open. I generally keep unit test windows open because I run unit tests all the time on my projects. Good question though. Can definitely be hidden. Did you have something you wanted to look at?
Yeah, could you scroll up? Just to the
You want to
top
look
of
at the
this?
adder class?
Yeah, I'm getting some red squigglies and I don't know what it's doing. So
Okay,
I'll
Harper, could
figure
you
it
help
out.
with that? Just for red squigglies? Yes.
So what,
I think I've got the dependency correct.
the information that we copied and pasted from, I think, the program into the facts section?
Yes.
What is that supposed to be? Like, for giving tests, is that supposed to be like
So which one should it be? Because this one is like
an
dependent on this one.
example, or like an
Right,
instance
because I
of
hooked this
this thing
dependency up
working
to
and what
this
it
one.
should do?
Like
Something like that?
Yeah. So the question is about the fact that I copied and pasted from that old program.cs some of the code into the body of this method under fact. I think the question is just like, how did I know to do that? Like, how did I know? So the adder class does some work, right? It's got a couple methods on it and then a hidden values list. There is really only one way to test this class. If I wrote a test that only called add, that wouldn't tell me anything. And if I wrote a test that only did calculate, it would always return 0, right? Because I had never added anything. It would just be 0 all the time.
I've seen this a couple times. You may want to cover it.
Okay.
With the namespaces being different, having to add the using in the since it's in another project, like having how to get a reference to that.
Got it. I will
'Cause I've
cover
seen
that
a couple
again.
people where that's.
Yep, I'll cover that again. But let me resume.
Okay.
So if we called calculate, like if we instantiated an adder from even a console and immediately called calculate, it returns a 0. And it returns a 0 because we instantiate it with a 0. There are no items in the list, so this loop never occurs, right? It never iterates. Then we would just return a 0. Well, that's not really a great test because calling add by itself and never calculate, or calling calculate never calling add, this class is useless. It doesn't do any value. The only time this class is valuable is if we call add at least once and then call calculate at least once. I could have written unit test to only call it once, but I didn't think that was very profound of a test. Doing an addition equation where it only has one operand, meaning if I just have the number 1 in, of course the calculate returns a 1. I mean, that's not really impressive. I needed at least 2 calls. I just arbitrarily decided 3 was good. So back to your question, the only way I can really know that I've written the class correctly is to fully exercise all of its methods, of which there are 2. So when I wrote the test, I had to instantiate it. Remember, I can't test something I don't have an instance of. This is a class. So I had to do the instantiation line. That's a given. I can't test something that doesn't exist. So I had to make it exist by creating an instance. I had to call add at least twice. I simply arbitrarily decided to call it 3 yesterday, so I decided to call it 3 times here. I didn't have to. But I needed to call it at least twice because addition is only meaningful when there's at least 2 things in the list. Okay? And as I said already, that adder class is not valuable unless somebody calls calculate on it. The whole point is that the addition occurs in the calculate method. So I had to at least do the line that I've highlighted here, calculate. And the last line is the one that's really weird. That's the thing that differs from everything I showed you yesterday and today. I need some way to make the computer test the result. Without this line, this test auto passes because I made no assertions in it, which means it's a useless test. Because I could have 20,000 bugs in it and it would just pass every time. I needed to tell the computer, hey, would you please double check that the result is correct? And in this case, the correct result is 6. So that is my explanation for how I knew all those lines should be there. I could remove one line. I could remove one of these adds. And I could change the 6 to 3. And that's still a fine unit test. But if I removed many more, it's not a good enough test to even write it. I need to call add at least a couple times, because I'm trying to add at least 2 numbers together. And I need to call calculate at least once, because I need to do the calculation. And I can't use a class without instantiating it. So necessarily, I can't get away with not typing these 4 lines. That's the minimum number of lines to do a test. And in order for the test to have a potential to fail, I need to have at least one assertion in it. That leaves me with these 5 lines. And now that I've recoded it, I can run this test again. Remember, I removed an add, so now we're adding the numbers 1 and 2. We should get a result of 3. We're asserting that there's a result of 3. If this works, our test will pass, and I predict that it will pass. Was that helpful? Was that clear? A little more clear? I'll answer it even a second time in a different way. You want to write your test code in the same way that whatever the real code that would use your class would use it. The whole point here is to mimic its real use. So when you go to buy a car and you do a test drive, that test drive is a real drive. If you were trying to buy a car and they said you want to do a test drive and you said sure, and they put you in a simulator, like a VR, right? You could go 0 to 100 miles per hour in less than a second. Now it could take you to Mars and back. It had oxygen tank. Like, the VR would be a lie, right? It wouldn't be an accurate test. You really want to test it as real as possible, which means you want to get in the real car and really execute it. You want to hit the real gas pedal, the real brake. That's how you know you're willing to shell out, 20,000 bucks or something for a new car. Same thing here with the unit test. I want to use that adder class in the most realist, accurate way possible to exercise it to verify that it must be working. It would be very difficult for this class to be written wrong now and pass. And let me give you a couple examples. I can give a question, but give me just 1 second.
Yeah.
I want to break it. I could accidentally forget to type that add. That's one way I could break it. I could have accidentally left the body of that method empty. Do you think this test will pass or fail? You know I've broken the class is obviously not written correctly anymore. I apologize, it takes a little bit longer to run than usual. It's the streaming software, it slows it down a little bit. But I'll run this. So remember, I've broken the add method. Well, it fails. And you can actually see it did the assertion. It expected the result. Let me get the test code back on the screen. It expected the result to be 3, but the actual result was 0. Well, the result was 0 because this for each didn't iterate over anything, because values was empty because I never did the add. So that's one kind of bug I could have that could cause this to fail. I already showed you what the minus equals did. What if you accidentally initialize the total to 1? So it starts off with the number 1. Let's run the test then. So now I have a different kind of bug. A bug any of us could make. The 0 key is not necessarily close to the 1 key on the top of your keyboard, but it is on the keypad. What if you accidentally tried to hit 0 with your thumb, and the tip of your thumb accidentally hit 1? Well, we've written a unit test, we'll run it, the test fails. Notice the expected value is 3 and the actual is 4. It's 1 too high. So that's another bug that I could keep doing this for hours actually, I won't, but you could see that it really is probably written correctly if that test passes. And that's the value of the unit test. Question?
So there are a lot of logistical issues in getting, because they're in different projects,
yes,
the namespaces and the usings, it's like it's not seeing one thing. So can you go through that and then
yep,
show the Visual Studio, like the little hints and helpers for like adding the using? Like,
I'm not sure what helper you're talking about.
Like where you can right click where it shows like a little red thing and you can say like, add that.
Type it without the unit space? Yeah, got it.
Kill all your usings and just kind of walk them through that.
Kill all the usings. So let's re-emphasize where we are so we know the state of the world. I have a class library 1, the default name, with the adder class that I'm testing. You'll notice that it is in a namespace called class library 1. Okay, so anybody who wants access to the adder class is going to get through it by prefixing the adder class with class library 1 in some way. And there's many ways to do that. In my unit test, I actually already put that using in there. But let's pretend like I forgot that, because it's possible some people forgot that or didn't notice that on the stream.
Yeah.
Well, if I take out the namespace, look what happens. I get red. I get red many times. The red that matters is the first one. The first one is here. The type or namespace, sorry, my mouse moved. Let me pause it. The type or namespace name adder could not be found. Are you missing a using directive or assembly reference? Now, that tip is actually a really good tooltip because that's usually the mistake you make. But you'll also notice there's another line in this tooltip. Show potential fixes. This is another one of the benefits of a great IDE like Visual Studio. It is pretty smart at trying to take a guess at what mistake you've made. It has a little is that a light bulb icon? A little down arrow. If you press down here, its very first suggestion is to put using class library 1 at the top of this file. If I click on that, it'll type it for me, and the red squigglies disappear. So if you missed that part when I was assembling all this and putting this all together, that's one mistake you could have made, and the red squigglies actually give you a little tip on how to fix that. Now, if you have those red squigglies and you did what I just did, and it did not suggest the using class library 1, then you've missed a different step. The other step you could have missed is in the unit test project itself. Remember the unit test project's right here? The actual class library we're testing is right here. They are siblings and they don't know each other exists by default. Yes, they're both sitting here next to each other, but they can't see each other. There's an opaque wall between them. You remove that wall by going to the unit test project, dependencies. I right-clicked, I did add reference. It pops up this pop-up, and you should have a checkbox right next to the class library we were pointing to. And I did that up front. If there are no checkboxes on this list, that's your boo-boo, no problem. Find that class library, check mark it, click OK, and then either your red squigglies will go away, or you can do that step I just did, which I will do again. You might be in this situation where we have red squigglies on adder. You've added the reference, so the unit test project can see the class library, but you've got red squigglies, and you can ask the computer to type the solution for you, and then it will work. And all the red squigglies disappear, and this would work if I tried to run it. I think that's probably sufficient. Yeah. Yeah, that one, that's something we haven't done yet. We had used the using before, but we hadn't used it on our own projects on a cross-project reference. So, and that's the order you want to do it, by the way. You always want to do this step first. You want to do the add reference from unit test to the class library you're testing first, and then those usings will actually make sense. If you do them in the other order, it can be harder to type because the IntelliSense doesn't know what you're trying to do. So add that reference first, then add the usings. Or in this case, we cheated. We let the computer put the using in for us. Were you good with the how to type the body of the unit test, how I knew to type that stuff?
Yeah.
The general answer is make it as real as possible, and make sure you fully exercise that class. In this case, the class is pretty simple. As long as there's at least a couple calls to add and one call to calculate, we're exercising every line in it that really matters. We're obviously testing that line. We have to test all of these, and implicitly we're testing the hidden stuff. Right? We're implicitly making sure that that was working correctly because this add is working. It wouldn't even build if I took that out.
Awesome way to play with your code without a UI, without even needing, you just write a whole class library without having a UI at all.
Absolutely. So Harper's comment is you can write all kinds of code in class libraries with no UI at all. And I want to stress, when you're new, that's probably scarier, right? Because everybody in this room has used applications before. You're using application right now. You've used websites. You're kind of comfortable with UIs. Like you kind of like having buttons and text boxes, and they feel very comfortable. But at the risk of being insulting, you're also spoiled because you're spoiled by that because the developers have done all the hard work on all those apps you're touching. They've done a lot of hard work. When you become a developer, the amount of code behind the scenes can be enormous, and testing every permutation of its use could be measured in years, man years. Like you would actually have to sit at your desk and alone, full time for years to test it. And with unit tests, we don't have to do that. Tests can run in milliseconds. I've been on projects where we had over 10,000 unit tests. They ran in less than a minute, which meant we were exercising the entire project's logic. Every single line was covered in less than a minute. There's no way a human could ever do that. None of us will ever be that fast. We're just not designed to be that fast. So, and just to sort of reemphasize Harper's point, you can test a lot of code even when the UI team doesn't even have a design yet. So even from a project management point of view, unit tests are valuable because it lets you as the developer write something and confirm that you wrote it correctly, even though they're still arguing over what colors the button should be. So there is no UI, there's no HTML yet, there's no CSS. You can actually complete large swaths of your project's logic without any UIs. And that will include what we'll talk about next week, which is connected to databases from C#. You'll actually be able to automated test all of that too, which means you can test all of your stored procedures as well. You can actually end up in a world where you can sit back in your chair and be like, yeah, there's no UI, but I already know it all works. You can be confident that your code works, not because of ego or something else, but because you have tests that have guaranteed that you've written it correctly or so close to correctly that it'll probably not have any bugs in it. Any other questions about my adder class or my adder unit tests or this test explorer? Anything from Winston? It's almost exercise time. It'll be a combination of break and exercise, just for the record. So we had another class yesterday. For me, it's in Console Lab 8, so if you're in the Git repo, it's this one. We had a name processor class. It was very similar to our adder class, right? It had an add method and took in something, but it did a little extra work. It fixed the capitalization, and it had this filtering mechanism, get names starting with. Here is the exercise. I want you to create 2 new projects. One's a class library, one is a unit test project. I want you to put in that class library, you can copy and paste your little name processor here. You can copy and paste the whole thing if you want. You don't need to retype it, but just like I did with the adder here, get it into that new class library. And then write at least one unit test in the unit test project to test this class and make sure it worked correctly. So it's going to be pretty much synonymous with what I just showed you. The name processor class is a little bit more complicated. Your unit test will probably have a few extra lines in it. But write enough of a unit test that you're sure that name processor works correctly. But don't run a console and don't use the breakpoints. And that's the exercise. And I will do my normal thing. We do a break first. Yep. So we'll go ahead and officially start the break now. During the break, I will type up that spec and I'll leave the stream running. We'll come back, we'll do the exercise. Let's resume, I'm thinking maybe 11:20. I mean, I'm feeling like this one might be a little while with the references and stuff. 11:15. I'll resume at 11:20, but I'll leave the stream running. Break time.
Do you mind writing the exercise out?
I'm going to write it here.
Yeah, perfect.
Yeah. I need to create a new library to put it in. But I will type up the spec for everybody to read soon. That should do it.
I think it's real.
It's never work.
It is. It's like, go let have it up. Plus it helps, like, if you're having trouble on other pieces, right, you test it, like, to play with it, here's your way to, like, get some good, get some good like, feedback on your own code. Yeah. I was like thinking about, like, way back the other day, it was like how handy it is just for, like, if you're doing, like, a line or two of code.
Yes.
And I was like, you can just write a unit test for that. And realistically, like, to get it to, just use it as a runner.
Also, it's really, it's never too early to try to learn this to whip away security from your device. If all you want to
Well, you're right. If you're writing libraries, there's no other way to really do it because, like, you're not gonna.
Right.
I mean, creating like a stub, like a web UI for all of your library code would be insane. I mean, talk about.
You'll be distracted by it.
Yeah. Well, yeah.
It's really distracting.
Yeah.
I don't really realize that when it comes to like this particular topic, we're really
Yeah. It turns out the crazy kid, you know, like he's like really even like the value testing and stuff. I mean, to a certain degree, he does, but he doesn't like.
I figured
with
this out. I figured this out when we were talking about it. On the phone. I remember I was staying on that outside. I was talking to him. And I made a comment that was probably the most interesting was instructor for English class. I made a comment that somebody I knew that I was talking to said that they were angry because that day, at the end of the week, they had laid out the business. When they do a test, it was the time blocked off for that. And they put that immediately because the customer ripped off the list. I told them, I'll leave it there. My suggestion to them was, I like not to give customers the opportunity to tell me the insights here. That's what the pressure got, blah, blah, blah. And my week is the week. And no need to screw with me. It's like, well, you're going to be okay if I talk about it, right? Since for me, it's not an option.
Yeah. No, it's.
I would never tell a customer, hey, do not do the thing that makes you know I'm capable of work.
Right. It's.
I don't put it, it's not an option.
It's one of the first things I teach in our internal like sort of above camps or whatever. But I do it in the, I mean, usually the middle of some point in testing. I usually now actually it seems like it's common. It used to be like, oh, yeah, use Microsoft test or whatever.
Yeah.
Okay, we use X and mock and different different things. Use theories, data driven things. And so I more like walking through that kind of thing, and then how we have it built in the CI, and how we have that. It's more of like the logistics of here's how Sightsource does it, but. And I think, you know, it's like unit testing. It's like, why is this important? It's like, okay, you want the second that people really get CI, then they're like, oh my god, I see the value here. Like, oh, you made this thing that I want to have so on. Like, is it going to have progression by somebody else? Like, 2 months from now, like, that's when it's like, okay.
I was giving the room a whole
but I never need to be, you know, it's like, just, as long as I get a little, I have it on,
Green check mark.
I have it on Slack, it just pops up, I'm just like, yeah, good, okay. And sometimes around the corner, sometimes like the grocery store, whatever, I'm just like, yeah.
And I assume that at least one person is like you will continue to
Yeah, all the time. All the time. Yeah. Yeah, computers do that a lot better. Yeah, when people talk about like value, oh, testing is going on, it's like something like, okay, how much do our corrections cost? How much do components cost? How much do, all these other things?
why would you you have to try to put a number on that. You have to know how to measure the value beyond that.
Exactly.
So if you really think regressions are okay, how would you talk to say working?
Especially,
How would you talk to customers?
especially on things that if someone is like frustrated with a certain thing like not working a certain time, and then you got it fixed, and then it regresses, that's like, it's over, you know?
Yeah, you understand. That, well, like, even into like regression, we need to spend a man last year. But which customers, like, which individual ways they were angry?
Exactly.
I guarantee you, there might be a team that's doing the business, they're very unhappy. That never is zero.
Yeah.
It's our job to be like, I'm very passionate about this.
Yeah.
I really care about the product. I really care about the customer care that they're bad. Because you get to see that, I don't know what they solve for it. I don't want sales teams to, I think that sales teams, the big information. I make a mistake that makes it harder to say, I'm effectively true. They don't respond well. Don't respond well to that at all. That's what they should be. They should be very angry with it. So let's just not have these things being very much. This is how professionals do their work. But what's the optional we take on this? I don't put it
That
as
being,
mine.
that being said, I don't believe in 100% coverage, right? It's like, if you know,
I'm
you
sure
know,
most of it.
yeah.
None of mine.
Right, right. But probably like the super hairy thorny things that keep on coming up progression probably
Yep.
are like.
They're more than 100%.
Exactly, like two different ways, right?
Yes.
Exactly.
That's where my risk is.
Yeah.
Mitigating risk is all I'm doing.
Right.
And I can never get that to zero if I can get it low.
Yeah.
to the Solution Explorer once I removed it, because yesterday's stuff was not here, which I guess must have been me, but I had a namespace that is in here, but it's not in.
Do you have a name processor anywhere from yesterday?
Yeah,
Okay, where's that at?
right here.
Okay. So, yeah, we can cheat a little bit. On the file system, just copy and paste that file from its old location. So just literally click on that file and copy and paste it.
So I kind of want the whole thing so I can run it and remember what was happening. That's what my goal was. I guess it's not super necessary, but I didn't return anything with the name processor. We just printed a list to the console.
Right.
Which is like not that. So I need to just return that, I guess, and then check the list. I don't know.
Well, you're welcome to open the old project from yesterday and play with it to your heart's content. What I don't want you to do, and that's why it's written the way it is, I don't want the program.cs in the new class library. I want the name processor to be the only class there.
Oh yeah. I'm not.
So you kind of have to pick. If you want to run it like you did yesterday, you need to open the original project.
Yeah, that's what I want. That's all.
Okay.
I want.
Well, then you can. What do you? So you're doing open file. Let's cancel this. Let's do file open. Project. And you can open the project from yesterday, which will be an SLN file somewhat close to that other name processor. You can review that old solution.
This is where it was.
That would actually be good enough. You're not opening the solution, but if you know that that's the right project, you can go ahead and double click it. And Visual Studio will basically open the single project and creates like a temporary solution for you.
Ooh, and how do I get back to the old stuff?
You can only have one thing open at a time per Visual Studio instance. So you can either go back and forth, or you can open a second copy of Visual Studio and open the new stuff and work with them side by side.
Okay.
You can open as many as you want. Visual Studio is a memory hog. You can probably open up 2 or 3 safely. Usually you can open up like 5 or 10.
Okay.
Bog up the whole system.
Okay, crap. Now I need to get back to the old.
Yeah, so you can open up a new copy. You can shift click on the icon here and it will open a second copy of Visual Studio.
Hmm.
You have to hold shift. I think you held it.
Oh no, I wasn't trying to.
Gotcha. There you go. So to open a second one, you can have them side by side if you want. So you can have the new one that you're working on now, which is old one. You can toggle back and forth. It's like 2 different windows.
Right.
It is a beast though, so you don't have to use that one. It'll probably do that.
So now, see how you do it?
Wow.
So in class library 1, you could add that, the name processor class, you could add that. Yeah, it's okay for it to have, multiple classes. Okay. Yeah. That one right there.
Mm-hmm.
It's nice though, I like it. Also, these things are kind of helpful too. The roll-up one. Yeah. It's helpful when you're trying to find like a symmetry problem, if there's a missing brace or whatever, because you can like find that innermost one, collapse that, kind of collapse, keep on going until you find like where it's, where it's missing something, where it's not closed out.
Okay. Mm-hmm. Sure. Well, and you see the description. There's really 2 projects. So you have the first one. And then you test it. You now need
Pick one, that's right.
a class like that. So you have a second project also. So I want to sort of create this.
So that would be nice.
Well, those, so it is actually possible for you to test to console. Yes, it's very bad. But I think that's my stay here. I'm going to use that library. So more people are getting players that one console. So although it's
Okay.
Well,
we're testing the name process and let's get one of those notes already. It doesn't utilize it or is it new class library? Okay. Yeah. Okay. So there's I did right. So that's the class library is one of the current. Yeah, that motion that has the name process. If you could check out that, copy and paste that in as long as they didn't have library on. Do you have Git? I want to another step. There is a whenever I do use lines, create a new and then we'll go back out to the roll of it out. Yeah, good. It's called the enforcement system. Yesterday was. If you pull back all of that code, you actually have the name process of it. That's a good stuff.
I see the problem. Okay, so this can't be the same, this can't be the same class name. So like your test, normally speaking, your class for your test is gonna be like whatever the class you're testing plus test, right? So
Well,
the process of test.
That should be the name of.
Yeah, you're getting like a class collision there, yeah.
Okay.
There you go.
Alright.
So in the same namespace, or you have things connected by reference, right? Those references, you can't have the same name. It'll get a conflict.
That makes sense. Alright.
That's fine. That's where you just go. Because I knew I could do this. That's the correct name process. If you click on that.
This one here.
Yeah. You could copy and paste all of that into that class library to class called name process. Where you have it is up there.
Albert?
Yeah.
You can right click on name that class library.
Are you trying to make a new one?
Yeah.
So is this your this is your add or test? Okay. So to create a new one, so
And give it the same name.
you're gonna want to go up in that solution explorer up there. Just go kind of all the way to the top, like if you click inside here and then just scroll up. So you right click there. You add a new project. And so you can name this one whatever you want. This is gonna be like your test for the for the exercise. So yeah, you can keep that as test project.
So it's here,
Yep.
you can
Yep.
Yeah, so that'll add that. It's helpful too. Usually what I do is if these things collapse over there, so whichever ones that you're not using, you can collapse. You just click that little
So now you
thing right beside the name, and it'll shrink it up. So that way, only the one that you're kind of working on. There you go. They can kind of see how it's going. So now that name processor class is in that other solution. So like the one that's out on GitHub there. You could just go to GitHub and pull up that one particular class and just like copy and paste it out there. That's what I would do instead of like getting the whole thing. Yeah, because it's just one class. And that's the cool thing about GitHub is you can go to I think it was called Day 14 was the name of the repo. You can just go to like the repo and actually look through all the code.
Okay.
A lot of times I do that and sit when I'm trying to figure something out. Like I won't even pull it down. I'll just like look through there and be like, oh, that's the problem. So you just I would just copy and paste that class down.
Thank you.
We're pointing out projects, not the actual file.
Okay, so it was,
I think it's class library.
that's what it was the first one.
And yeah, so the name processor is in the exercise for the
So stay tuned the process of new stuff.
just that name processor class is like an example.
But the really cool thing is at the end, whatever my search is.
Yeah, so as long as you reference that class or that project from the test project, then it'll be wired up.
Arrows in the test spec. Oh, yeah, yeah.
Everything you can wear up again?
Yeah. Yeah, I'm trying to text him.
It's like a voicemail from like someone from DCU. Something about all the speech I'm supposed to be using or something. I know there are two Patrice Grays at this school. I know that for, or at least at some point there was. They're in the same class together. What? It was weird. At all. She tanked her final. I did pretty well on mine, and our grades got switched. So I spent like a year and a half. I'm like, hey, you've got to fix this. I feel like she's like they didn't change her grade to her, you know, what she should have gotten. I'm a little pissed. But yeah, that's weird. She's not much of a student. I don't think she'd be doing this speech
I guess it might be before they explain the J.
That's usually this. Messages, probably if I call her back, or answer, she'd be like, I just need your social.
Like, she's, the concepts are the same.
Yeah. They look great.
Yeah, they look very similar.
On one hand, I feel like we got it either works or it doesn't.
It's cool. Is he rapping? Is he like doing the show?
Yeah. I've known his music since like, I was in 8th grade, but like, seriously, that was like my favorite album.
Yeah. Most likely it's cool.
with some Fast and Furious one.
That is cool. He's so multi-talented.
Theoretically speaking, children are my Teslas, all the rest. So, no, it's not really. That's why I use this.
I don't think that news for my friends to that's okay. There's something else that I can
Because I call like the entire list, so I can directly check all of the features.
But one of these big things that most people do is
Iceland, Nigeria.
oh, Nigeria's gonna lose, aren't they?
I hope so.
Yeah, they really disappointed me, man.
But they got beat by Croatia. Right?
They did. I mean, Croatia was good, but like
Croatia's
Nigeria,
dirty,
terrible.
man. Croatia's dirty. Croatia beat Argentina 3-0 yesterday. Argentina sucks, of course, but
Didn't Messi play?
yeah, he did. But it's not that end of their deal that's the issue. Right, I'm only a third Steve. I don't know what to do. That's all I got left. Where you guys at?
You put the start statement in there already.
No, I don't know how to do the assert statement. Because we're trying to, it returns a list, and I Googled it, and it says that it doesn't work for lists, for collections. So there needs to be like a view assert statement or something, which I think I'm just wrong.
Oh, there you go. Okay, I forgot about it. Oh, thank you.
Res the time yesterday is because I read that laptop jumped out and there was I put the old version to this edit on it.
Good start.
I didn't have the C++ redistributable. I had to go into Windows Update and get all of that stuff. It took a long time for it to catch up.
Conserve energy for the next 10 hours at lunch.
It's just tripping out trying to do the whole
It has more ground.
Which did?
I just don't know, so. This is my test. Got a class. It's the name processor. I know it works. It spits out 2 names when I put this input. capital B Bob and capital B Bobby. And I don't know what to write into the assert in order to run my test.
Staying up on questions and stuff, and I was like, well, you know. So part of the
used this test
some of them are
before,
very,
so
like,
I would
are
just say
like,
go and
can
Google
you
it and ask what the
go over
command
thing
that you
you're
have to
on
write
now?
is.
Some of them are like a thing that was from like last time, and I'm like, all right, I'm gonna ask that. I'm not gonna interrupt.
What did he do?
I'm gonna ask that at the end.
He just did assert
If,
type.
if somebody wants a review on a
But
prior
then it
thing,
said-
it's
but
like,
I
I'm gonna wait. I was like,
And it
it's
is.
like that, but just.
It also doesn't
You know,
recognize
we
my
can't do it right
list,
in the middle of
even
the
though
meeting.
I've definitely got
So,
dependencies.
I'm gonna
I definitely got
continue
using
to
app,
ask
console app 1.
things that are,
This is class
that are
1
going
from
on,
console app 1.
you know?
Yeah.
And I definitely
If
returned
there's a question about
list.
what you're doing right now, if there's a question that's
Probably
you or
can't
like a
sit
hey,
there
go
and run
this thing or
equals on
whatever,
a
an
list,
hour ago,
right?
yeah.
They would have to iterate over
I just told them to be
everything in
like,
list.
I got you.
So they're not
I'll ask.
individual things, so maybe,
Just give me some time.
maybe you'll separate them out and then see if it works.
But it doesn't even, like, this collection thing runs to
Exactly.
check a couple of things.
Exactly.
But some
I don't want to get you like off the topic right when you're in the middle of
if they're
something.
behind.
So the first one is the name of the collection, the second one is the number of items in the collection, and then I could do another one to check things about the
Right,
items.
Okay, hold on. So we do have one.
Where it drops down
So-
and tells you. What is the word?
Naming class of projects,
Suggestions.
Smart.
IntelliSense?
IntelliSense. But it doesn't even recognize my new list, even though it's right over here. Like, I don't know why it's not linked up right.
Good luck, I don't know, tell you, man.
Just keep them
Alright.
the name in their project and classes the same. There's
Okay,
like
okay.
that.
Yeah.
This is,
There was.
this is new for me too. I usually write
What you
this
did when
object
you
oriented
showed
code in
like
Java.
the usings and kind of walking through that, I think completely fixed that.
C#?
They were, I think, at one point getting the
They
same
are very, very similar, but
thing that was kind of
the different commands and stuff that actually identify things,
But I think that
I don't know, so I have to go and look them up. I've been doing deck on the deck.
And I feel like
I'm doing it all.
I can tell you one thing though, you can do like the type of stuff which I used to do, which is to just sit there and initialize and set each variable individually, and then go through and then just write it out each line. Every time you change something, every time you set something new to see if it actually returns the way that it's supposed to at the end, because it's going to execute line by line, so.
Well, I
you
know
can set
that this
something, write
code,
it
I
out.
copy and pasted this from over here.
I
And
mean,
this one definitely.
I would throw in that concept as the next thing.
When
the next
I
class
when I
we're
run
building,
this,
the next
I've got the
whatever. If you
program
wanna
which
say,
is
like,
copy
you
and
know,
pasted
as
into
a
the
as a
test.
mini review.
So when
test
this
or
goes,
whatever, be like, okay,
it's the
we'll do
exact
this in
same
the
thing,
context,
except that
we'll
it
sort
joins
of,
the
you know,
list together
fill
and
out this
spits it
new
out.
class or do this new.
But it
new
puts it through the
concept,
name
whatever, in the
processor, which
context
is
of-
the exact same
that would
class as
work
is
those
in the
together.
other one.
I'm not
When I
sure
run
how-
this,
I wouldn't do
it
just a.
makes the new list.
like
It
those
calls
two
the new
test first
list.
thing.
I'm saying,
And
Just for that.
just now when I ran it, if
I think
it doesn't die.
Here's what I'd like to do.
Oh, as a follow-up for this exercise?
Yeah.
It breaks and
Yeah,
doesn't work
absolutely.
apparently.
Absolutely. Yeah,
Okay.
yeah.
I'm gonna do a new name processor.
A couple seconds ago this worked.
Maybe that's the place to start.
Show how it feels first.
Fail.
Perfect. Yeah, no,
I
I
will
think
write
that's
a band
perfect.
that's long, like
Yeah.
just do the capitalization fix, and then write the get with.
Oh, now it works.
And it'll
Yeah.
fail
That's
even
bizarre.
though They might expect it to work, and then I'll fix the caps.
Yep, I think red green, and then maybe do like one of them like kind of verbose, you know, or like do it like a long way,
Like,
a red green refactor.
what I was thinking is I could do the capitalization in the other method, the capitalization we done before in the read, and then move it, and show that the test didn't fail, so I moved it successfully.
Yeah.
And I could make sure that maybe the first time I didn't move, I'll do it wrong. I'll
Even
accidentally-
the second time, do it like a little verbose, and then be like, is there a way we can clean this up? And it's like it's green. I'm going back and refactoring it. So it's still green.
Right.
Like no regressions. This is how you can refactor without regressions. That's what you said the other day when you're working. It's not done, right? So you can show that like this is a way of refactoring safely, right? Because it's like my test was green, now I refactored, and now my test is still green, and I know.
I'm gonna do all that, and that takes us a while.
Okay.
We'll do it on step.
Are they ready?
Yeah.
Because we're a little bit late.
Okay.
Let's double check.
Watching them with other people, but then I get freaked out when I watch them by myself. Like, I
Yep.
like doing that.
Good? All right. All right, let's resume. I know some of you reached some great conclusions out there. Some of you got about probably halfway or so. That's okay. This is another one of those exercises that I'm going to do it in front of you. I'm going to do a solution in kind of the style that I would do it, and it'll be close to how we did the adder class. I'm going to change up just a couple things for you, but I won't go too crazy. And I'll show a couple new techniques that might be valuable for you. So we'll just review the exercise. We're going to create two projects, a class library and a unit test project. We're going to use that old name processor class. That's the class we're trying to mimic from yesterday. When I did the adder, we copied and pasted it. As I suggested here, you're welcome to copy and paste it, but I'm actually going to show you how we can build a class without copy and paste. That'll be kind of fun to watch, hopefully, for you. We want to write at least one unit test. You're welcome to write as many as you want. A lot of classes and many projects, we usually have many unit tests. I'm going to write at least one. I might write more, we'll see. And I just wanted to make the note, remember that name processor really does two things. It does the casing fix on the first letter of the first name, and it also does the filtering. And in order for your test to really be valuable, obviously it needs to test both. You either need to have multiple tests or at least one good test that exercises both of that. And I just made a note here because when you're learning this stuff, it's easy to forget, and a couple people did, how to add the reference, a project-to-project reference, and how to reference via namespaces. So I'm going to do this from scratch, right in front of you live. Once again, I did not practice this exercise. I'm just going to sort of do it on a whim, and we'll see how this goes. And I'm actually just going to close that class one so it's not confusing. So the first thing is, I need a class library where I'm going to put this new processor. And I'm actually going to do better names this time. So I'm going to do a class library. This is nothing more than an assembly, a project, that's going to contain all my classes. We're just going to add one, though. I'm going to call it processors. That's what this library is going to contain. It's going to contain a bunch of processors. Right now it's going to contain just one, but its job is just to contain those. So we create that in our solution. And I'm just going to delete that first class. You don't have to do that, but that's what I'm going to do. So I've got a processor assembly, and it's hidden down here. And I'm immediately going to go ahead and create the unit test project for it. I'm going to choose XUnit, just like I did before. And I'm going to call it processors.unit tests. This is just a convention. There's nothing technical you're watching here, but it's very common for unit test assemblies to sort of share the base namespace that they're testing, and they'll add something like tests or unit tests or automated test as a new set of words after the dot. The dot's just a separator. It's a cosmetic separator. It's not critical. There's nothing really technical to it. The benefit of naming them well like that is that they kind of bunch up together right here in the Solution Explorer. So both the class library and the unit test library are actually right next to each other. I'm going to delete that initial unit test class because I'm going to write a new one from scratch. So right now I have two empty new projects. One's a class library, one's a unit test project. They're sitting isolated from each other. I've deleted their original files, so they're completely devoid of all content. They're completely empty. The first thing I'm going to do, because it's so easy to forget if you don't do it first, is definitely point the unit tests project to the class library. That way I can see into it. So we right-click on dependencies in the unit test project. We look at this big long list and we pick processors. That's the class library. It's going to contain all our processors that we want to test. And you just think of it as, how do your eyes work? Your unit test assembly must look at the thing that it's going to be testing. It's got to be able to see it. So that's the direction that we must build this reference. If you build it the opposite direction, it's possible to build it that way, but it won't serve your purpose. So I'll just go ahead and click Save All because I can. Now we've got them ready. So let's start creating that processor. Now I actually said in the spec you're welcome to copy and paste the name processor. I'm going to use the old name processor as a guide, but I'm actually going to write it from scratch. If you're following along, feel free to copy and paste it because I'm going to do this part kind of quickly. But I'm doing this for a reason, which I'll show you in a moment. Oops. So I'm in the class, my brand new class library, creating the new class name processor. I'm just going to sort of reset it. Be sure to make it public. If you don't make it public, the XUnit project, the unit test project, won't be able to see it. So go ahead and make it public. And I will copy and paste the methods, just to stub them out. I'm going to type something you haven't seen yet. We're going to be talking about exceptions later. All I'm doing here is basically saying if anybody calls add, be sure to crash the program. That's what that says. We'll talk about why I typed that later on. I'll be deleting that line. That's why I don't need to go too deep into it. I'll be deleting it so it won't be relevant soon. But I'm going to put it there temporarily. So stubbed out the name processor class. Now that doesn't look like the one I typed yesterday. Right? The one I typed yesterday is actually useful. Right? It's got this field of names on it. The bodies of the methods actually do work instead of crashing my application. My new one is sort of stubbed out. So what I've done here, I know that I want a name processor. I know how the other code is going to use it. It's going to be calling add and passing in names, and it's going to be filtering and getting back sets of names as a result. But I'm not going to put the code in yet. I'm showing you a technique. It's kind of an advanced technique. If the technique bothers you, don't worry. You'll warm up to it later. But the general term that I like to use is called test-first development. Not test-driven development. That's a different thing I'm not going to talk about in this course. That one's popular, but I'm not going to talk about it. But I'm going to be talking about how we write tests first and why. So in this case, I have a name processor. I know how it's supposed to be used, but it's completely broken right now on purpose. And I'm going to leave it in that state for a moment. I'm going to go over to my unit test assembly and go ahead and add a new class to that. And that's going to be my unit test class. So I'm going to call it name processor tests, because that's the purpose of that class. It's going to test that other name processor that is not yet finished. I'm going to put in using XUnit, because that's the framework I'm going to be using. I'll make that class public. And it's time to write my first test. Now you'll notice I'm about to write a test when I already know the class is broken and unfinished. The actual class I'm testing will not work. That's okay. It's okay to write tests first, and in fact, there are a few teams, not too many, that insist or really pressure the developers to write tests first. That's actually my style. It's not the most popular, but you're going to watch me do it here. So remember, I always have to use that attribute fact. That's how XUnit knows the method I'm about to type is a unit test class. And I'm going to assume I can write this all in one method. So I'm just going to say, I'm going to give it a bad unit test name. I'm just going to call it works correctly. And I'll improve that name if I need to later. I just want to sort of get started. I want to be kind of impatient, just get started on the test. Now the name processor class is in a different namespace. Question?
Yeah, can you take the camera off real quick? Just turn that in OBS. It's like blocking something.
Yeah. I know what it's blocking. It's blocking the bottom here. I forgot about that. I kept pointing to it. So I apologize to Winston-Salem. I've been talking about these two projects here at the bottom right. So processors is my class library that contains the class I want to test, which is currently only partially implemented. And I spelled this wrong. I'll fix the spelling. Processors.unittests is the name of that one. That contains my unit test class that I just created. And I made sure that this unit test project is referencing the actual processor's other project. So we always point from unit test to the other one. So they probably didn't see all of that because it was at the bottom right. I apologize, Winston-Salem.
They say, can you make it really small because it might cover code on the other side even?
Well, actually now I can go to the top right. Okay. Because those assemblies are going to stay at the bottom.
Okay.
So we should be good now. So I apologize for that. So we are back to the unit test project, looking at that this works correctly method. Bless you. I want to go ahead and get some code typed in here. So think about the name processor. What is it supposed to do? And just to sort of remind you, since we talked about it a lot yesterday, and I don't want to be overwhelming, if we go to that old code we had from yesterday, this is how we use that name processor there. Right? We instantiated it. We put a lowercase Bob, uppercase Alice, blah, 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 blah. We had these 3 variables, and I used a breakpoint yesterday. But what we're talking about right now is unit testing. We don't use breakpoints. We don't use console.writeline either. So I can actually cheat, can't I? I can cheat right now. I'm going to copy and paste this code. There's nothing wrong with doing that right here. I'm going to go to the name processor tests class, and I'm just going to put that in there, and it gave me red squigglies, so it's already unhappy. The reason it's unhappy is that name processor is in a different namespace. And if we look at the top here, I've only pulled in system and XUnit. It doesn't know about the processor's namespace in the processor's project. I haven't brought that in. But as Harper made me point out earlier, I just hit Control period just now. That's one hotkey you can use. Alt Enter also does the same thing. It pulls up the hint, and this is where Visual Studio is trying to help you. It's asking, did you mean to pull in the processor namespace? And my answer is yes. Bink. And all my red squigglies disappear. That happened to a couple people during the exercise, so it's good to sort of get in the habit of getting these things pulled in. That's how we do that. Now, this code is pretty good. Yeah, we'll leave all these. So we're using the class in the exact same way you saw me use it yesterday in the console application. But what's different about unit tests, as I've already said, we're not going to be using console writeline or our eyeballs or breakpoints and debug data to figure out if this ran right. We need to do some sort of assertions. Right? We need to assert that everything is going to work correctly here. Remember, the class is currently broken. If that's bothering you, just hang on with me. It's okay that the class is not actually written correctly yet. We're just working on what would the test, how would we write the test to make sure that if the class was written correctly, the test would pass. So we're focused on just what are the inputs and outputs in this test. So we're going to have the Bobs. According to my visual scan of this, we should have 2 Bobs in that list. Remember, I'm going to put my mouse over. We were returning lists of strings from that get name starting with, so we can do a little bit of assertion here. Let's do a few assertions. I'm going to do a few of them. I like to write really, I don't want to say aggressive, but really detailed assertion sets. So let's first start with the quantity of Bobs. How many should be in that Bobs list? Anyone?
2.
2. Yep, I had a few people say 2. So let's assert that the expected value of 2 is Bobs.count. I happen to know that the list object in C# has a count property, and it's exactly what it sounds like. It's just the number of items in that list. It can be 0, 1, 2. Hopefully it's 2. Let's do the same thing for the alleys. How many alleys should there be? There should there should also be 2. That's correct, because we have Alice and Alina with different capitalization. All right. What about Charlies? How many Charlies should there be? All right. 0. I heard somebody say 0. That's correct. Now we are going to see green squiggles. This is just a very opinionated message. If you put your mouse over it, you'll see what it says. Do not use assert equal to check for collection size. Well, I can press Control dot, and it wants me to use assert.empty. Okay, I'll do that.
Oh, I think it's for Alice. Isn't it A-L-I-C?
Okay. Ali, it's A-L-I-S.
What thing did you press to hit the
Control period. Control dot. That just pops up the little helper for you. I use a lot of hotkeys because that's faster than a mouse for me. I keep my fingers on the keyboard a lot. Good question though. Control dot gave me that help, and so I'll do it again. I'll do an undo. If you're doing assert equals, because after we did the first two, your instinct is to use a 0 for that count, but it's considered, it's an opinion that it's a bad practice. We should use assert.empty. That's fine. Remember, I told you that all these unit test libraries come with a large set of assertions you can make. They just want you to use assert empty when it's an empty list. Okay, I'll do that. There's nothing wrong with that. So they should at least have those quantities in them. And now, let's I was just given a message about a time limit, so I'm going to make sure I might move a little bit quicker here. We can always pick up and review this after lunch, but I want to get more typed here. So we have quantities and we have empties. Let's do some other assertions. What I'm going to do is use some variables, and I'm going to steal out the different bobs. You don't have to do it this way, but this works. I'm going to pull out both bobs into independent variables. Lists are kind of like arrays. You can access them by index. So I'm going to pull out all the ones I know about. So Ali 1 would be Ali's square bracket 0. My brain wants to type allies. And there are no Charlies, so that's going to be fine. So those are the 4 that I should get out. So you see I'm just directly pulling them out. The reason I'm pulling them out into variables is I want to make some assertions, and I want them to kind of be easy, and I didn't feel like writing a loop here. You could write a loop, but you have to ask questions about the index. I think this is kind of an easier way to read the unit test. It's not the only way to write it, but this way will work. Okay, and so let's do some assertions. Because we're pulling out strings, we can very easily do equals. The first one should be Bob. So we expect to find Bob in Bob1, the value. Remember, I returned a list of strings, so if I put my mouse over Bob1, it's a string. So the first one, Bob1, should be Bob. The second one, however, should be Bobby. And you can just follow along. It's not the most exciting code to write. It's kind of linear, kind of tedious to write. One mistake that you're very likely to make is to accidentally reference the wrong variable here. So pay close attention to the 1s and the 2s. So the first Alice would be Alice, and this will be Alina. And while you're typing that, if you're typing it, we can sort of look at the screen. If you look at this, you see that I'm fully using that class, right? I'm adding 4 different names of different capitalizations. I'm getting 3 sets out of it. I'm asserting their length. So the lengths are the first thing I assert to make sure that the quantity is correct. Then I pull out all 4 of the items I know should be in there based on the data I input here at the top. So that data, I knew there should be exactly 4. And then I make actual assertions on the values that they are precisely the right values located at precisely the right place in those lists. If all of these assertions pass, it is extremely likely I wrote the class correctly. It's not a guarantee per se. I could still make a boo-boo. I could still have an imperfect unit test. But it would be very hard for a massive bug to pass this test. And we can already sort of give that a shot. And for those that are typing, I'm going to scroll to the bottom in case you're still typing the end of that. You'll notice my Test Explorer has explored and found it sees the old test that wasn't passing, but my new one is right here. This not run test is the name processor test. I'm going to go ahead and run that. Do you think it will succeed or fail? Succeed? We have 1 vote for succeed. Any other votes in either direction? Time's up. Now you can't vote. Fails. It fails because I didn't write the code yet. Remember, those methods are actually empty right now. And we do have a limited amount of time, so I'm just going to start quickly typing what I think should be the solution. I could copy and paste yesterday, but I want to show what would happen if we just start typing. So I need that original. I will do a little copy and paste just to save a little bit of time. I do know that I'm going to have to store in that class a private set of names. That's good. Here I'm going to do names.add name. You can see I deleted the exception throwing code, did names.add. Now if I go ahead and run the unit test, will it succeed or fail? No one's brave enough to predict. She says it should fail because I haven't fixed the second part. That's correct. Now it's actually taking a moment to run. This laptop is slow when I'm streaming. Runs it and it fails. And in this case, you can actually look at the message. It will fail because get name starting with string threw a not implemented exception. It exploded. We'll talk about exceptions later in the course. So I have to write the code here that I want. So I'll cheat a little bit since we are limited on time. I'll copy and paste that original code from the body of the old name processor from yesterday's to here. I'll press save. Should it succeed or fail? One vote for succeed. Any others? I want one more vote. Be brave. Succeed. I hear something up here.
Succeed.
You gotta succeed. Failed. This is okay. What you're watching is an iterative process. If we look at it, assert equal to actual 1. So one of these asserts that wanted 2 values only got 1 back. What did I forget to do? I'll go back to the specification, wherever it's at. Make sure to test all the critical functionality. What did I fail to do? The casing. I did not check the casing. So the old name processor had 1 extra line in it, right up here, where we fixed the casing of the first name by uppercasing the first letter. If I bring that into the processor I'm writing today, paste that in, run the unit test, don't be scared, pass or fail. Pass. We'll run it and we will see. And I did, when I was putting this together, I left out that new name on purpose because what I wanted to show you is it's very easy to leave out a line of code. When we're talking about millions of lines, it's very easy to leave out one and have the code appear to be written correctly but not be complete. Names, add, new name. So I actually made a real mistake in front of you. I added the line and I forgot to use the variable I declared. And someone in the audience noticed it and was probably expecting that to fail. Boom. Fixed it. Now I'll run the test. Pass or fail. That's a good example. I really screwed that up. That was a true mistake. But I'm a little bit more hopeful now. Pass or fail. Oh, people are brave now. They've been predicting success so often, and it's been red every time. It's green. Passed. So with about 1 minute left before lunch, we can save questions till after lunch. I want you to appreciate what I showed you. I wrote a test that completely was written so well, I'll say, that it was really stringent. It was really strict. I really had to write that class correctly. And I had it written wrong, get through exceptions. I fixed one method through exceptions. I filled in code in the second one through an exception. I added a line, copied and pasted with an actual mistake I made. Still didn't throw an exception, but failed to work correctly. Fixed the boo-boo with my new name variable, and then it passed. Now, what I want you to go to lunch with is the appreciation of the act of writing a test first. And you saw how fast it ran. Right? If this were a big app and it took you 10 minutes per test, that would have taken me an hour to show you me improving it, because I made about half a dozen fixes along the way. But since these tests run in literally milliseconds, and I just ruined my UI, so let's bring it up. Since it literally ran in 96 milliseconds, my iterative time to fix my own mistakes was tight. And I want you to go to lunch with appreciation for how fast I can do my job when I write tests first. We have a hard cutoff. If you have any questions, save those for after lunch. You want to go to lunch and come back at 12:50? Let's do 12:50. Thank you.